Okay, so now we're in the PDI area, or pre-delivery inspection area, where we double check and re-inspect every CRON coming out to the field. The purpose of bringing you down here is we have the machine with all the covers and skins off so we can show you more detail inside the machine. Stepping back to plate loading, I'm just going to show you the manual load table. You can start with CRONs with no automation whatsoever and have a manual load table where we load a plate manually on top of the plate load table. You simply push it in, move it to the right against the plate registration block I showed you on the H model earlier, and then the machine will do the actual load onto the drum, registration, imaging and punching. So the manual load table is very simple. You slide one plate at a time onto the table, right justify, the CRON does the rest. Okay. So what we're going to show you now is an actual plate imaging sequence. So the plate's already on the load table. You're going to see the imager drive the plate into the external drum. CRON use external drum technology because it's the most accurate. Gives you the smallest spot size on the imaging. The drum flatness is less than 5 microns, best in industry. After imaging, we have our punch units. On this machine, we have one punch die set installed. We can support multiple die sets for different presses, so we can support all of the customer's printing press punch requirements. And then on the exit, we have a simple exit to take the plate out to either a plate stacker, a gum unit, or clean out unit, or a plate processor, depending on the plate technology. So let me kick off an imaging sequence. So now it's registering the plate before driving it onto the external drum. The tail clamp will close. It's now going to do a temperature compensation on the focus. We have dynamic temperature compensated focus on the CRON. And then the drum will start spinning. And the imaging head will traverse across the rear of the drum, sliding on its linear magnetic drive, which we'll talk about later. And you'll be able to see the little reflection of the UV lasers. This is a UV machine, not a thermal. We do both technologies, imaging the plate as we go through. After imaging on unload, you will see the punch cycle occurring. So now we finish imaging. The plate is going to come off the drum, but still be in register. We'll see the punch cycle. We use pneumatic punches, so there's no motor to wear out. Then the plate will eject out the rear of the machine. And another design feature of the CRON by design is the layout of the external drum. Our external drum is placed high in the frame. It's well balanced. We'll talk about that afterwards. What this allows you to do is get very efficient plate loading and unloading because the plate is coming in right near the top head clamp on the drum. So the distance to load and unload the plate on and off the drum is very small. And this can actually gain us up to 3 plates an hour productivity by design versus the competition, where they generally have to take the plate down in the base of the machine because the external drum is sitting in the base frame on their designs. So here you can see the plate is at the preload position, either from the loader or the operator. And here is the head clamp on the drum, currently open. So when you go to do a load plate sequence, the gap is very small between the plate load and the head clamp. So it's a very small movement to load the plate on the drum and consequently unload it off the drum at the end of imaging. Now we're going to show you the CRON magnetic linear drive system. So here where I'm pointing, you can see we have a rail with super magnets across the width of the drum. Imaging head, you're going to see scan in a minute, is floating on those magnets, just like the magnetic levitation trains you see in China and Japan. So if we kick off the carriage move, we'll see now the carriage coming across on its magnetic drive. The advantage of the magnetic rail system is there are no moving parts. It's a floating head on magnets, so you have no wear parts. There is no chance of grease hardening. With a ball drive like the competition uses, once the grease gets hard, or over time when the ball drive gets backlash, you'll start to see imaging artifacts in your flat tints. With the magnetic drive system, you're good for life on the system. There are no touching points, no wear points. So It's a key technology feature of CRON. So the CRON laser head systems are accurately cooled using a liquid cooling system. So on the right here you'll see our coolant tank. This is using glycol, which you can buy from any car parts store. We don't sell the consumables. The liquid is flowing up to the imaging head and then back down through a radiator here, where the fans are blowing out the air through the radiator to complete the loop. So it's a closed loop liquid cooling system. We have a top-up tank, and basically in the field that will just require checking and topping up once per year. So here we have the lower side of the optics imaging head off of a thermal system, showing you where the liquid cooling comes in here. So the liquid cooling is going through, in this case, 3 cooling chambers. We have 2 mounted underneath the laser diode head. This is cooling the heat away from the diodes, back down through the radiator and back to the liquid coolant tank. And on a thermal system we have a 3rd cooling system here, cooling the laser driver boards. On a UV system, because they use much less power, we don't need to liquid cool the laser driver boards. So again, it's a closed loop system, fixed cooling chambers with our 2 pipes going back to the lower coolant tank. So another improvement CRON have cut in the G Plus and the H models is the auto oiling system for the fixed bearing rails for the imaging head. We have a V-shaped guide rail and a flat bearing rail at the back of the imaging head. In the past that used to be a greasing for the service engineer once per year. Now we have a small oiling bottle with a small pump, and this will dose the rails automatically from the LeBou software. So this eliminates the need for that yearly maintenance visit on greasing the rails. That's our auto lubrication system. Okay, so on the CRON drum design we have 2 balance blocks on each side of the drum, just like most external drum CTPs, and these are there to balance out the size and weight of the printing plate attached to the drum during imaging. So I'm going to point out now this is one of the balance blocks. If I turn the drum round, we have the 2nd balance block here. These get moved automatically by the LeBou software based on the plate size and the plate thickness that you're loading onto the machine. Sure. Well, one of the big things about CRON technology is what we call redundancy, especially for printers. By using the fiber-coupled laser diode technology in our design, it means that you as a printer will never be down in the unlikely event of a laser diode failure. We can just simply map out as an operator past the failure point of the CRON using our LeBou 1-bit TIFF server. So I'm going to show you how simple it is to overcome a failed diode and keep making printing plates. Okay, so in this example we have a 32 diode G Plus machine here, and let's assume for the moment that laser diode number 7 just failed in the middle of your key production. So if we open up the template for the press, any template, you'll see here at the moment I'm using laser channel 0 to laser channel 31, the full bank. If laser channel 7 just failed, then the biggest bank left is going to be laser diode 8 to 31. So as an operator, I would just come in here, change the 0 to 8, hit the confirm button, and my machine will now continue making plates using diodes 8 to 31. The machine will produce plates more slowly depending where the failure occurs, but the key thing is you're still making your printing plates. With most other competitors' designs with single head diodes or single diodes or GLVs, when you have a problem with the imaging head or the diode, you're down until the service engineer arrives. With a CRON, redundancy is key. You keep producing your plates and therefore your print jobs.